Okay. George, the floor is yours.
Okay. Hello, everybody. My name is George Farconis, and I will present the business case of Cyprus in the ENVISION project. First, let me just put the presentation on, share the screen. Okay. I guess it's visible now. Okay. Well, first, a brief introduction. Capon joined the ENVISION project in mid-2020, aiming to explore new approaches and co-develop technology and services about the coming checks by monitoring and area monitoring system in the framework of the new CAP. Given the absence of regulatory framework back then, the design of the business case was a clean sheet and more of an intuitive approach rather than an informed decision. This, of course, presented itself as an opportunity, as there was no bias towards a certain direction. The timing of the project was right on the transitional phase from the previous CAP to the new CAP, and allowed for adjustments and fine-tuning over the course of time so as to reflect to the latest developments. Specific points of interest for CAPO were, of course, the main services of the project, the crop type mapping, various analytics on vegetation and production of time series, and finally, cross-compliance monitoring on certain GAICs and SMRs. The initial CAPO needs included crop classification required, vegetation status, distinction between organic and conventional farming, and soil organic carbon. Additionally, we identified areas of cross-compliance that could be monitored using various analytics, which will be showcased later on. Specifically, non-compliances with GAIC 1, GAIC 4, and GAIC 6, the descriptions are on the slide, as well as illegal interventions in Natura areas could be identified. Last but not least, a mobile app for farmers and inspectors, which would act as the service of geotrack photos, either for farmers to prove some action or eligibility condition, or for inspectors to control a parcel. Then the regulatory framework was finalized in 2022, and the strategic plan of Cyprus was approved in the third quarter of 2022 also. In the meantime, CAPO had created the infrastructure to apply checks by monitoring and communicate results to farmers for the first time. Following the successful implementation of checks by monitoring, the decision was made to apply the area monitoring system for 2023 to certain measures, specifically BIS, the areas with natural constraints, and a certain enviro-climate intervention. This is the sun disinfection of the soil. All these factors contributed to the finalization of this business use case and allowed for adjustments and fine-tuning. The story so far. Through an extended data exchange, analysis of the input data, and a series of technical discussions, we tried different approaches which would allow for increased accuracy of each service. Various datasets were utilized to achieve actionable results. One thing that stood out during this process was the ever-changing declaration dataset of the current year, which was made possible by the new regulatory framework. Applicants could amend their applications as late as 30 days before the final payment, and that created a challenge to be tackled. With the guidance of our partners, the idea of on-demand access to data at any time and any location took shape and led to the creation of a unique service that will be showcased in the following presentation. Some results from the services. The first image shows a vineyard which has been classified with a confidence of 99.99%, similar accuracy to other crops or crop groups. The second and third images show erroneous declarations by farmers, which, if left unrectified, will eventually lead to penalties. So the second image shows a declaration by the farmer as barley, whereas the classification service has provided the result of potatoes. And the third image, the declaration was about fallow land, when in fact it was a clear case of bananas. A more detailed description of the process will follow, about the crop type mapping, I mean. Moving on, results from the burn scar mapping service. Here the service produces an alert with various parameters such as the date and the severity of the event. The results are at the disposal of the paying agency, and the intended use is to alert farmers immediately after an event and provide guidance to the farmer for required actions. Another example here is the identification of non-compliance with GAEC 4, which states that vegetation should be maintained during the raining season when the slope of a parcel exceeds 10%. Results are generated and can be communicated to farmers immediately, informing them of the non-compliance and providing guidance for them to avoid repeating the same action in the future. This is the idea mentioned earlier, where CAPO has created an FTP repository for on-demand results, either at parcel level or at the application level. Results consist of a visual representation of time series of an array of indices, as well as related graphs, to allow for inferences to be made on the actual status of vegetation or a specific attribute of a parcel. This could be useful for the expert judgment process. A more detailed description of the service will be provided in the following presentation also. ENVISION has also created a platform where a stakeholder can have an overview of the results from the various services. The platform allows for extended search capabilities, upload of datasets to be analyzed on the fly, and the wealth of information at parcel level. Insights gained from our participation in this project. Cyprus is a small country with a significant number of small parcels with little available pixels to proceed with meaningful classification. The need for use of other image products apart from Sentinel images emerges. Results from 2022 show a percentage of erroneous declarations. Having alerts in place is important for CAPO to achieve a more correct and representative declaration dataset. Moreover, trials on various conditionality requirements provided promising results for certain standards, which can be considered monitorable down the line. Also, a user-friendly mobile application to allow for the take of geotag photos is an important element towards new CAP. It is a means to transition from non-monitorable to monitorable interventions, which we will need by 2025. And finally, smart sampling, a derivative of crop type mapping service, can offer early alerts and enable the paying agency to focus on high-risk areas or applicants. And with these insights, this concludes the presentation. I would like to thank you for your attention.
Thank you, George. Thank you very much. If you have any questions, we prefer to do them after the second presentation. And now I will give the floor to Jason for their own presentation. Thank you.
Hello, can you hear me now? Maybe. Great, thank you. Thank you, George.
Yes, thank you.
Let me share my screen. Okay. So my name is Jason Sardanidis, and I am a research associate and data science from the National Observatory of Athens. And I am working for the technical part of the ENVISION project, and more specifically the creation of the Earth observation data products in order to cope with CAPO needs. And today I will present you some of the insights, some of the lessons learned for this Cyprus business case. My slides are moving on, so it's okay?
No, you should be putting presentation.
Okay. Sorry again. Is it better now, I guess? Okay, now, thank you. So the main objectives of the ENVISION was to create and design the Earth observation data products in order to address the CAPO needs and make the job of paying agencies and monitoring tasks more efficient, accurate, and less costly. Our services are mainly based in order to monitor the agricultural practices and later on improve the impacts and improve the general task on the environmental supervision of the environmental practices supervision. Our first product and the first service that we provide in CAPO is the cultivated crop type maps. This is a well-tested machine learning and deep learning service that is based on the current state of the art and provide a series of dynamic crop type maps for every group of sentinel acquisition. The results are provided at national scale are provided either on a pixel or parcel-based approach. For the creation of these crop type maps, we are taking into account some Sentinel-2 and Sentinel-1, the available Sentinel-2 and Sentinel-1 images, as well as some vegetation indices produced using these images. Also, we are taking into account the scene classification maps in order to detect cloudy pixels and improve the accuracy of our algorithms. Based on this cultivated crop type maps products, we are put in practice our sophisticated algorithms in order to create more accurate and more precise detection maps and give at CAPO some alerts with the most probable cases that have been declared wrongly. The level of accuracy is improving as long as the period is moving on, the cultivation period is moving on. And at the end of the cultivation period, probably CAPO has the ability to detect with higher accuracy the cases of the wrong declaration. Also, based on the results, we are able to provide some cross-compliance maps in order to cope with greening requirements such as crop diversification. The case of Capo is mainly characterized by large amount of cereals and fallow lands, and that's why we have devised our crop categories in higher taxonomy categories in order to improve our maps. As we can see mainly from the vegetation signatures, some categories such as cereals or fallow are very difficult to be distinguished between each other. These curves are characterize the vegetation identities of each crop, and we can see that is far more difficult than we initially expected to be this task. Also, as George Farkonis mentioned previously, the percentages of wrongly declaration is quite high, and this creates an initial problem in our training routines. So it is some issues that we need to overcome. Some issues arise in order to overcome these limitations. Also, a very characteristic case is the case of fallow land, which is the most frequent case that is wrongly declared, probably for some intentionalities. And since our training process is based on the actual declaration, is make our training task much more difficult. Also, some other limitations that have been arised is the size of small parcels, that is roughly 0.3 hectares, and also the multi-cultivations that are parcels that are including more than one crop type. And let's moving on now to the current performance. In comparison with our initial experiments and trials, now we are in case that we have improved quite much our quality. Actually, we have improved significantly the amount of alpha error, which is the error that characterize the cases that have been correctly declared, and also we have ameliorate the beta error, which is the error that correspond to the cases that have been declared wrong. Now we are at the level of performance of around 0.8 of accuracy. And actually these results correspond to cases that have been, that are based on remote sensing samples, remote sensing validations. And we believe that the actual ground truth accuracy is a bit higher than the visualized one. As I mentioned before, also we are able to provide some smarting alerts. And as you can see here, we are providing some maps with the level of alert, with the dangerous level, that the cases based on the level of confidence of the crop type maps have been categorized to the specific level of danger. And as you can see here, we can see a sample of this service visualized with different colors. The red one are the most dangerous one. Here we can see an example of one case that have been identified as an alert. It indeed was probably a wrongly declared case. As we can see from the figure on the bottom of the page, the orange curve, it visualized the average declared case, which in the specific case is the fallow land. This case have been declared as fallow land, and the green curve depicts the average curve of the predicted label. This case have been predicted as vineyard. The actual curve of this case is the blue dot line. And as we can see here, the curve of the predicted one and the actual curve of the field is quite similar, while the orange curve is far more different. Also, from the picture on the top, we can see that is for sure something that is not fallow. It's more close to a vineyard. Also, we have, based on the universal, based on the European system of crop diversification, we are able to provide the crop diversification map based on the categories the categories provided from the European Union. In addition, we are at place to provide analytics and vegetation and soil time series. Actually, these are products that, in order that our main scope is to address the monitoring of good agricultural and environmental condition and statutory management requirements. For that reason, we have developed some services in order to identify the proximity to waterways and some runoff risk assessment for nitrate vulnerable areas, the minimum soil cover and soil erosion for areas that have a level of inclination higher than 10%, as George mentioned earlier, stubble burning identification, cases that have been cases that fire have been take place, the fire of the stubbles, in order to address the GAEC 6 requirement. Also, we have moved on with the detection of illegal activity on Natura 2000 regions. And at the end, we have provided also some comprehensive GIS analytics in order to help the evaluation process from CAPO, providing some clever visualization and some robust analytics. As also, as mentioned, we have created some complex queries that are based on our very modern data cube technology. Thanasis Drivar, which is my colleague, later will provide some more details regarding that, and some clever visualization that have been created by us in order to help the validation process by CAPO. Analytic functionalities, as mentioned earlier, can help for the validation and visualization purposes. Here is an example of temporal statistics for a predefined area in order to see the evolution of the activity of the area using some vegetation indices throughout the cultivation period. Also, some extra pre-processing steps can easily take place in order to improve the level of accuracy of our results and provide a solution that can improve the value of our products. Soil index time series that can help for minimum soil cover and runoff risk assessments as really critical too. One of the CAPO demands is to detect soil activity in order to cope with raining season. And here we can see in the first picture some cases that have been correctly identified as alert cases that have a slope of higher than 10% and vegetation and soil cover higher than a critical point. So we identify them as an alert in order to help CAPO cope with this requirement. Also, in order to help for the naturally vulnerable areas, we have provided a runoff risk assessment algorithm based on a Russell equation for that purposes. Stubble burning identification is taking into account multiple vegetation indices and burn indices also in order to identify event of fire of stubbles throughout the cultivation period, which is prohibited. Last but not least, we have the Natura 2000 hotspot detection, which identifies cases of activity inside Natura areas, which is not permitted. The results are provided also in pixel level and some point polygons, some point layers in order to help the detection of the dangerous areas. And as far as moving on, we have very encouraging feedback from our users. So to conclude, we are at place that we have that we are providing a product in order to help the monitoring with continuous monitoring of vegetation and soil over time. The scalability of our product is one of our targets, since this product is designed in order to provide accurate maps for a small area to entire countries. Also, generalization of purposes and cost reduction have been taken into account. Early detection is also one of our initial objectives, since we want to provide on-time analysis and alert maps and warning maps in order to help for any future potential problem. And last but not least, customizable analysis. So every new and every need that have been identified is easy to be reconstructed in our systems and provide some results of high quality. And now we'll give the floor to Thanasis Drivas to give some visualization of our front-end platform, our front-end algorithm for capo monitoring.
Thank you, Jason. Good morning, everyone. Let me share my screen and close the unnecessary tabs. So, can you see my presentation?
Yes, it's fine. Thank you.
Great. Let's start. Okay. My name is Thanasis Drivas. I work as a full stack developer in the Beyond Center of Excellence for National Observatory of Athens. And today I'm going to showcase a powerful tool that have been developed in the context of our collaboration with Capo. But before I begin, let's introduce the DataCube, which is the backbone of our services. DataCube, Open DataCube is considered to be a framework that tries to simplify the process of organizing the EO data, the Earth observation data, and in specific the satellite imagery, because it's quite difficult due to its volume and complexity. So this tool, this framework, make it easier for us to develop our products and to handle all this power of EO data. However, despite the fact that it simplifies the process, the power of EO data is not even unlocked. So we need to go a layer above and create a new application that aims at leveraging the power of open data to make satellite data accessible for everyone. And I mean for data scientists, domain experts, decision makers, policy makers, etc. In this presentation, we will show how a web application takes the data from our DataCube, creates graphs, plots, etc., and ingest this kind of information to the in-house software developed by the most of organizations. Because the most of the organizations use their own software, so they have to take the data from us and ingest it in their framework, in their software. What we have until now, we have organized and managed to give to the users data coming from Sentinel-2 satellites. So it's optical data, optical bands, vegetation indices such as the NDVI, the NDWI, etc., and backscatters from Sentinel-1 GRD data. The way this application has been developed is via famous technologies such as the Django framework and the Django Ninja API, along with famous and mature technologies and libraries such as the Matplotlib and the Seaboard. The idea is here the users to make requests, these requests on the fly being processed by our system, by our technologies, and then give back to the users visualized the information, which is very crucial because they are not just data, they are just numbers, they are visualized so the users can identify patterns and features such as the vegetation or water bodies, for example. Let's focus on the use case of Cyprus now. What is the flow here? What is the workflow? We have users. We have users that makes requests to our system. We load the data from data cube. Then we create a time series of plots and graphs. We automatically, all this is an end-to-end pipeline that is fully automated. I'm sorry. And these generated graphs are being uploaded to a dedicated FTP, a dedicated repository of from the capo. Then the users from capo, the decision makers or the data scientists can get enough information to be sure for the validation process to enhance this general decision making. This is a simple scenario. Let's go and see it happening on real time. Let's go back to our browser. This is the web application. As you see on the left, there is an HTML form that users can enter their parameters. And which are these parameters? This is the IDs of the parcels. We have exchanged some shape files, so we do know the IDs of the parcel. Let me, for example, set the number 4 here. This is the band that the user can select in order to get back the plots. So I can use, for example, the NVI, which is a famous index. This is the minimum percentage of cloud that actually is on a parcel. So I might need a very clean, very clear images, very cloud-free image. So I say to the algorithm that I need at minimum 70% of cloud percentage among the parcels of the among the pixels of the parcel. This is the buffer zone because I may need to see what's happening in the entire area, so I can extend the buffer around the parcel. And this is a time window, for example, 2022, 1st January until 2022, May 1st. If I click the submit button, there is the whole process that takes place on the back end. And on the front end, users can see what are the some metadata of the images that have been uploaded to the Capo's repository. So you can see that we found these images that are cloud free. There might be another additional images, but they have been deleted from the process due to the cloud free percentage. There's above the threshold. So these images were automatically created by the process. Let me show you what I mean here. Sorry to close this and too many windows. So if I go here, it will take just a moment to find the appropriate folder. It's here, the request. So as you can see, date modified. And this is the file name of the generated image. As you can see, it is number 4, the ID, the time window, and the selected index band along with the cloud free percentage. And if I open this one, you can see that the users take a time series of images that you can see also a bounding box here, which is the selected parcel, the geometry of the parcel, along with the images on every timestamp and the color ramp that indicates what its value represents, its color represents to this time series plot. It's not only this that is being generated, but also a graph with the average value of the NDVI. Can you see? So here we have a drop. That means that something may happen at this specific timestamp and then goes again up. It might be cloud or it might be an event. This is something that we have to analyze further, but this is the first information the users takes in order to see if something took place. So back to the presentation. What the future work includes, despite the fact we have already and ready-to-go application and it is active, couple uses exploits this application. However, there is always room for improvements, and we can make this application work connects to the database, so to take automatically a certain category of parcels to generate images for them. For example, all the alerts that JSON service has been generated for the crop classification or the grassland mowing event detection. So it will load all these parcels instead of user writes down the IDs and generate this kind of images. We can add, of course, many more indices based on the CAPOS needs. We can, except from the average value that you saw in the graph, we can also add a standard deviation and median to be more representative and to add value here. And of course, we can give back, except from the plots, the actual raw data, the values for each pixels, in order, in case the data science of CAPO want to make an analysis, a custom analysis, and not base on our analysis. So we can provide results coming from our own analysis as NOAA, but also we can feed them the actual data so they can make their own analysis. That's all from my side. Thank you, everyone.
Thank you, Thanasis. Thank you, Jason, for the earlier presentation. And now the floor is everyone. Everyone is welcome to ask any questions if they have for the presentations that we just watched. No questions? Okay, will thank you all, and we will wrap it up here. Thank you very much for your time and your presentations.
Thank you for the presentations. Thank you for
Thank you, George. Thank you, everyone.
Thank you, everyone.
Thank you.
Have a great day.
Thank you and goodbye.
Thank you.
Thank you. Bye.
Bye.